Oh, she's sweet but a psycho. Word problems. Today we get to apply everything we've learned about all those graphs and throw it in a real life word problem. So when you ask yourself, when are we going to use this in life? Well, here is an example. Let's say you are working for the school board. The school board is investigating various ways to hire teachers and aides. The amount of money the school district will have to spend on salaries each year depends on how many teachers and aides are hired. So a lot about budgets. New teachers are paid $15,000 and aides are paid $10,000 a year, which obviously those numbers have been made to make these numbers work a little bit better. But yeah, teachers don't get paid $15,000 a year, and neither do aides. All right, but let's go ahead and define the variables and write a cost equation. So if I let x equals teachers and y equals aides, let's see, how can we write a cost equation? How much does it cost the school board to hire using x and y's? Here it is, the cost equation, 15x plus 10y equals c. Notice instead of 15,000x and 10,000y, I've decided to take away the 3 extra zeros to make our equation work a little bit better, so it's working with smaller numbers. But you should know that whatever answer you get, you're going to have to multiply it by 1,000 to accommodate for those 3 extra zeros. All right, so that's how we write the cost equation, how much it costs to hire teachers and aides. And now I'm going to give you some restrictions, because you can't just hire, you have to have some sort of restriction when you're hiring. So I guess the new building can accommodate no more than 50 members. So how do we write that as an inequality? The new building cannot accommodate, can accommodate no more than 50 members. So no more than 50 members. Well, think about it. We have teachers and we have aides. There can be no more than 50 members. There it is. X plus y has to be less than or equal to 50. So the number of teachers and the number of aides have to be less than 50. What about this one? A minimum of 20 members must be hired. So you have to hire 20 members or more. You have to. Let's come up with that inequality. There it is. X plus y has to be greater than or equal to 20. There must be at least 12 teachers. How do we write that as an inequality? There must be at least 12 teachers, the x's. There it is, x is greater than or equal to 12. The number of teachers must be at least half the number of aides. So the number of teachers must be at least half the number of aides. There it is. The number of teachers, x, must be at least, so greater than or equal to, half the number of aides, 1/2 y. It is impossible to hire negative teachers and negative aides. So you can't hire a negative amount of people. So how do we write that as an inequality? It's a little bit tricky, but you've seen it before. X is greater than 0, so you can't hire anything less than 0 for teachers, and then y is greater than 0. You can't hire anything less than 0 for aides. All right, those are all of the restrictions. Now guess what we get to do? We get to put it all in a graph. How exciting. Let's go ahead and graph all of these. All right, so as you can see, I have written all of the inequalities, the restrictions, the constraints on the top left-hand corner. The cost equation is on the right top-hand corner. We'll worry about that cost equation in a little bit, but let's go ahead and graph all of these. Let's start off with the green one. Notice that I'm only using the first quadrant because remember, these two right here, where I can't hire a negative amount of teachers or aides, means we're only going to use the first quadrant. So that's why I don't have the entire graph, I only have the first quadrant. And then the numbers I know we're going to use are going to be kind of big, so instead of going from 0 to 10, I'm going to go by 5s. So this is going to be by 5, 10, 15, 20, and then all the way up to 50 up there. And then same thing here. This is going to be 5, 10, 15, and so forth, all the way up to 50. All right, so you have to label your graph correctly, and then try to make everything fit. All right. All right, so let's go ahead and start graphing the green line. X plus y is less than or equal to 50. It is in standard form. I like to just keep it in standard form. Cover up the y, that gives me the x-intercept at 50. Cover up the x, that gives me the y-intercept at 50. There it is, going from 50 up there to 50 down there. Then we have to decide which way to shade, above or below. Using 0, 0 as my testing point, if I plug in 0 for x and 0 for y, I will get 0 is less than or equal to 50, which is true, so I will shade towards the 0, 0. Let's go ahead and do the blue line. Again, standard form, so I'm going to use the cover-up method. Cover up the x to get 20, cover up the y to get 20. We get from 20 to 20. Check 0. 0 plus 0 is 0, and that's greater than or equal to 20. Not true, so do not shade towards it. Shades away from it. So now we're going to deal with the two parallel lines and then everything in between. So keep that in mind. Let's go ahead and graph the yellow line. X is greater than or equal to 12. Remember, x equals is always the vertical straight up and down graph. So go ahead and find that at the 12. Now we have to decide if we're going to shade to the right or to the left of that. If you still plug in 0, 0, in case you're only going to plug in 1, 0, 0 is definitely not greater than or equal to 12, so do not shade towards the 0, 0. Shade away from it. And then the red line, that one looks weird. X is greater than or equal to 1/2 y. Go ahead and change it to the other form. Multiply both sides by 2. You should get y is less than or equal to 2x. Start at 0, 0, slope up 2, and then over to the right 1. That's what it looks like. All right, now we have to decide which side to shade. Here we cannot use 0, 0. 0, 0 in this case is right on our line, which means we cannot use it to test. So we have to use another point. So maybe test 1 point away at 5, 0. So let's see what happens when you plug in 5 for x and 0 for y. You get something that is true. 0 is going to be less than or equal to 10. So shade towards that point. There it is. Let me erase this a little bit so you can see the little arrow. All right, and then we have the two last ones. The x is greater than 0, y is greater than 0. That just means we're working in the first quadrant and so we don't really have to graph that. All right, so there it is. That's all of our lines in there. That's a lot of lines. It is kind of difficult to see where all of them would overlap. So take a real close look at all of them. Remember where it's supposed to shade, and then shade in only where they overlap. And there it is. Once we've done that, we've created the feasible region. All right, so from there, we're going to go ahead and find all the critical points. There's a lot of them. There's one right here. There's one right here. There's one right here. There's one right here. And there's one right here. It's all the corners of our feasible region. All right, and we have to find them all, which is not too difficult to do. We'll start off with the easiest one, this one right here. All right, it looks like it is at, I know it says 4, but remember we're going by fives. So it's 5, 10, 15, 20. It looks like we're going to be at 20, 0. So that's our first one. Check. This one down here, if we count by fives, it goes all the way to 50, 0. That is our next critical point. Let's look at this one. So this one's harder to tell because it's like not on a corner. It is somewhere in between. And the way we find it is we look at the colors. We have a yellow line and we have a blue line. So let's look at our equations up here. The yellow and the blue. These two. Now we have a system. To find out that point, we have to solve the system. This is not too difficult. You just make everything an equal sign now. Don't worry about the inequality. If you use substitution and plug 12 into this x right here, you do get 12 plus y is equal to 20. Subtract the 20 to the other side, and you should get 8. And that gives us our point right here at 12, 8. All right. If that was confusing, go ahead and think about it. Solving the two equations, you just set them up and use substitution. It's a little bit of work to do. Our next critical point is here. Again, that's kind of hard to tell what that is. It might be, I don't know. But to solve it, it is between the yellow line and the red line. So these two. And you can substitute it into the simplified version or not. It doesn't matter. It might be a little bit easier to plug into this one. All right, so when you plug the 12 into there, you should get y is equal to 24. And so that point is at 12, 24. All right, and then we have one more critical region or critical point left, and that's up here. And it's between the green line and the red line. So these two. All right, and then you can do substitution method. Take the 2x and plug it into this y. From there, you can solve it out. I'm not showing my work, but you can do that. X plus 2x is equal to 50. Divide both sides by 3. And you should get a decimal, which is not going to be a nice number. And then once you do that, you can go ahead and plug that number back into the x to get 16.6 and 33.3. So that are the 5 critical points. All right, not the easiest thing to do. It takes a long time. it works much better when you have graph paper. So make sure you're using graph paper when you do these, otherwise it gets real messy. I mean, I'm doing it on the computer and it looks like a lot. Now, the next thing, and now we're not even done yet. The next thing is to find the minimum feasible cost and the maximum feasible cost. The way you do that is you take each point and you plug it into your cost equation. Let's use red instead. Take all of these points and plug it into the cost equation. You can do that pretty quickly on the calculator, so go ahead and try it. If I plug in 20 for x and 0 for y, I should get $300,000. If I plug in 50, 0, we get 750,000. Plug in 12, 8, 260,000. Plug in the next one, 420,000. And plug in that last decimal one, you should get about 582,000. All right, so all of that are the restrictions for hiring teachers and aides. And now the district wants to know, well, what's the minimum feasible cost? So what is the minimum amount of money they can spend? And it looks like the smallest amount of money that they can spend is if they, oh, that's not the smallest. The smallest is right here. If they hire 12 teachers and 8 aides, that would cost the district the least amount of money. All right. What if they wanted to spend all of their money? All right. So the most money they can spend is actually right here, which means they'll have to hire 50 teachers and no aides. All right. So as you can see, this is a pretty elaborate problem, but it is also one of those things where you ask, when are we going to use this in life? And these types of problems are very real in real life. Actually, this one only had 6 restrictions. In real life, there are tons and tons of restrictions, and you have all these lines and they shade all over the place. And you have to find that little region where they all overlap, and then you have to find all the critical points, and then you have to test all of the points to see what gives you the maximum, what gives you the minimum. All right, and so we've just done a smaller version of something like that that would happen in real life. All right, so here's what we have next. Your homework is not going to be the usual homework that we have. It's going to be this problem. All right, I know it's the same thing we did, but it's a park cleanup problem. Go ahead and pause the video here, and then copy everything down, and you're going to try to do this on a graph piece of paper, and then we are going to talk about the solution in class. All right, so go ahead and try this, and we'll talk about it in class. But this will be your homework. Have fun!